guys. So quick review today. We're going to be talking about, yeah, y'all would like to actually be able to hear me. Today's quick review is ionic bonds. So ionic bonds are formed when a valence electrons, remember we did this, valence electrons transfer from one element to another. This is typically a bond between a metal and a nonmetal. These types of bonds form because electrically charged ions are attracted to their opposite charge, creating a solid 3D crystal shape. Pretty cool looking, actually. Okay, ionic compounds are also known for having a high melting point and the ability to conduct electricity when dissolved in water. Okay, go ahead and pause and check your answers, and then we'll move on to the notes for today.
So when we were talking about ionic bonds just a moment ago, I talked about you wanting to go to the bookstore, go to the book fair, and that your mom only had $15 to give you, and your mom had a 10 and a 5, and little brother got 5, and you got 10, and you had to work together. One person had to transfer the extra money over to the other person. Well, today we're going to talk about covalent bonds. And with covalent bonds, I still want you to think about going to the book fair, but this time they've got these cute little astronaut erasers, and they're normally 50 cents a piece, but today, not really, I make stuff up. There's not even a book fair right now, but today they're on sale, 2 for 75 cents. You and your little brother both want one, but you only have 45 cents and he only has 35 cents. So nobody has enough to buy one on their own, to buy the 50 cent a piece. And definitely nobody has enough to go buy 2 for themselves. However, if you share your money, you have enough to both get one. If we did the thing we did with ionic bonds, where one transfers the money over, only one person is going to get an eraser. This time we want both people to get an eraser. So we're going to have to share. Okay, so in your blank here, I want you to describe what we said we were going to have to do with the money, and make sure you use the word share, because that's the important word here, okay? So ionic is transfer. Ionic, transfer. Covalent, share. So in an ionic bond, the atoms transfer, or the electrons transfer from one to the other. In a covalent bond, the electrons are shared by each element. Yet again, everything that's highlighted in yellow means that it's a test question alert, means it's going to be on the test. So a covalent bond is formed when atoms share valence electrons. Unlike ionic bonds, which form between metals and nonmetals, so when we have an ionic bond, we have a metal and a nonmetal. Covalent bonds form between 2 or more nonmetals. So oxygen, for example, is O2. It bonds to itself. That's 2 nonmetals that bond together. Nitrogen is a nonmetal that bonds with oxygen, bonds with carbon, which is also a nonmetal, bonds with hydrogen, which is also a nonmetal. Any bonds between those elements are covalent bonds. In this example, we have the nonmetal fluorine represented here with its 7, because it's in family 17, 7 valence electrons, and then another atom of fluorine over here, which also has 7 valence electrons. But by sharing this one pair, they now both have 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Neither one of them is losing or gaining an electron. They are just sharing some of the electrons. Here's another way to look at that exact same thing. So this is more of the Schrodinger version, where we have a 3-dimensional idea. This is the path that those it's only 2 electrons, but those 2 electrons traveling back and forth make enough of a bond to pull the 2 of them together and make them part of an F2 molecule. Here's another way to look at it, but it's the same thing. The electrons from this one are represented with X's. The electrons from this one are represented with circles. And then there in red, it shows the shared pair. Okay, so let's draw some examples of what we're talking about here with a covalent bond where we share valence electrons. So the first thing you've got to know is how to draw an electron dot diagram. It's also called a Lewis dot diagram. And the way we draw them is to write the chemical symbol and then a single circle for each valence electron. So hydrogen is in family 1, so it has 1 valence electron. Carbon is in family 14, so it has, that's right, 4 valence electrons. And we would scatter them around the carbon like this. And that's basically what happens with those electrons. This is why so many living things are carbon-based, because carbon can make bonds on all 4 sides. It's like carbon's a 4-armed octopus. And it can make a bond here, it can make a bond here, it can make a bond here, and it can make a bond here. It can bond with itself. It can bond with almost anything else. So because of that, that's why carbon is so common in everything, because it bonds with everything. Nitrogen is in family 15, so it has 5 valence electrons. So we start by scattering 1 around each, just like on the carbon, and then the second one goes next to the one on the top where you started. And then oxygen is in family 16, so it gets 6. 1, 2, 3, 4, and then 5 and 6. Now, something like argon, and you don't have to write this one down, I just want to show you, but something like argon or one of the other noble gases has 8. And so that means they have 2 on each side, giving them the total stable 8. And that's how we know that argon is a noble gas, because it doesn't have any places open here to bond. So he's not going to bond with anybody. It's like a fully inflated balloon. He can't bond with anybody. These are all like bubbles. They can blend together. All right, so let's start with water. How would we draw the covalent bond of water? So we've got oxygen here, and it has 1, 2, 3, 4, 5, and 6 valence electrons. And then hydrogen has 1 valence electron because it's in family 1, but it's a non-metal. So that still makes it a covalent bond. And there we have H2 and 1 O. Now ammonia is NH3. Ammonia. So we're going to start with nitrogen. And it's got 1, 2, 3, 4, 5. And guess what goes to fill out each of those? Exactly, hydrogens. So we got 1 hydrogen here with that 1 electron. 1 hydrogen here with that 1 electron. And 1 hydrogen there with that 1 electron. Now, hydrogen only needs 2 electrons to be stable. So he's happy with 2. Oxygen now has 8. These are all happy with 2. And now nitrogen has 8. 1, 2, 3, 4, 5, 6, 7, 8. So everybody's happy. What about oxygen? So oxygen doesn't exist as O1. It's not stable. Oxygen by itself is not a stable molecule. O2 is oxygen gas, the stuff that's floating in the air that we breathe. O3 is ozone. So that's the stuff that protects us from the burning rays of the sun. And also when lightning strikes, we can smell ozone. You know that weird smell after a lightning strike or after there's like some electrical problem, like if there's a little zap and you get that weird smell in the air, that's ozone. You're smelling ozone, and you cannot breathe ozone. Even though it's oxygen, it's O3, and our bodies don't know what to do with O3. We need O2. So for O2, we're going to have one oxygen. I'm going to start with red because I've been starting with red. One oxygen over here, and it has 6 valence electrons. So we've got 1, 2, 3, 4. It's so annoying. And 5, 6. How come it won't draw a circle? Okay. And then we have our second oxygen here with 1, 2, 3, 4, 5, and 6. So in this case, these are actually supposed to go out here. My bad. My brain knew what to do. So here, this oxygen has 1, 2, 3, 4, 5, 6, 7, 8. This oxygen has 1, 2, 3, 4, 5, 6, 7, 8. Everybody's happy. But in this case, there are 2 shared pairs of electrons. So 4 electrons are being shared. What about carbon dioxide, CO2? So for this one, we're actually going to put the carbon in the middle, and every single one of carbon's valence electrons has to be shared. So we're going to put 1 here, and 1 here, and 1 here, and 1 here. Wow, that actually worked. Now we're going to have 2 oxygens, and they each have 6 valence electrons. So we're going to put 1 oxygen here, and we know that 1 and 2 go there, and then 3, 4, 5, and 6. And then this oxygen goes over here. 1, 2, 3, 4, 5, and 6. So we have 2 shared pairs between this oxygen and this carbon. This oxygen has 1, 2, 3, 4, 5, 6, 7, 8. This carbon has 1, 2, 3, 4, 5, 6, 7, 8. Everybody's happy. Now for this oxygen over here, we've got this pair and this pair that are being shared. But again, 1, 2, 3, 4, 5, 6, 7, 8 has 8 electrons. He's happy. And the carbon still has the 8 electrons it had before. So again, there's a double bond there of shared electrons. And finally, our good friend nitrogen. So nitrogen is written as N2. And we've got 1 nitrogen here, and it has 5 valence electrons. So we're going to have 2 here. Actually, they go here. And then 3. 1, 2, 3 in the middle. And then our other nitrogen, who has 2 on the outside, and then 1, 2, 3. So there are actually 3 shared pairs of electrons here. But in that way, everybody has 8. This nitrogen has 1, 2, 3, 4, 5, 6, 7, 8. This nitrogen has 1, 2, 3, 4, 5, 6, 7, 8. So everybody is happy. So what are those dots representing? Each time we drew a little dot, we were drawing the valence electrons. And how many were we looking for every time? Every time we had to get a total of 8. And obviously, that's a test question alert. You need to know that 8 is the stable full set of valence electrons for most atoms. For hydrogen and helium, they only need 2. But everybody else needs 8. All right, moving right along. Maybe. All right. The number of bonds that an atom can form equals the number of valence electrons needed to make a stable 8. So the nitrogen can make 3 bonds because it needs 3 to make that stable 8. The oxygen can make a double bond of 2 because it needs 2 to make that stable 8. If you missed notes 1F and you have no idea how to determine the number of valence electrons, go to the video that's embedded in the notes. Go to time code 707, and I explain how to easily find the number of valence electrons. But I don't want to spend time in this video doing it. So go back to that video. It's from the last unit. So anyway, I'm not going to harp on it. Moving on. Oxygen has 6 valence electrons. So it needs 2 electrons to make 8, so it can form 2 covalent bonds. In the molecular compound of water, H2O, oxygen forms 2 covalent bonds with 1 hydrogen atom each. So we already said that ionic equals transfer and covalent equals share. Well, now we need to talk about another thing. Ionic bonds make ionic compounds. That's easy. Unfortunately, covalent bonds make molecular compounds. Don't ask me why science decided to be mean and not just call them covalent compounds. But they aren't. Yeah. All right, so how do we remember all this? Well, I can remember co means share, like co-captains share the responsibility of being captain. When you collaborate, you share the responsibilities of the work. When you cooperate, you work together to operate the system. When we have collaborative classes and co-taught classes, you have 2 people sharing the responsibility of teaching. So co means share. Then for the other one, it's just a memory thing. Ionic, covalent, molecular. So how about we say those together? Here we go. Ionic, transfer, covalent, share. Ionic, transfer, covalent, share. Ionic, covalent. Good job. Now the other one. Ionic bonds make ionic compounds. Covalent bonds make molecular compounds. So ionic, covalent, molecular. Ionic, covalent, molecular. Ionic, covalent, molecular. Ionic, covalent. Good job. All right, nitrogen has 5 valence electrons. So it needs 3 electrons to make 8. So it can form 3 covalent bonds. In the what kind of compound? Covalent, molecular. In the molecular compound, ammonia, NH3, a nitrogen atom bonds with 3 hydrogen atoms. Now let's look at oxygen. In this case, we have 2 pairs of electrons being shared between the oxygen atoms, and that is called a double bond. How about the other one that we drew? What were the other ones that have double or even triple bonds? Right? And what was the other one that had a triple bond? Good job. So we had nitrogen had a triple bond and carbon dioxide had a double bond. So this is just coming from here. A molecular compound is a compound that is created from covalent bonds. So one more time, ionic, transfer, covalent, share, ionic, covalent, molecular. Pause if you need to get that, but I'm going to erase and move on. So here's just a model of a couple of drawings of atoms of compounds that are molecular compounds, compounds with a covalent bond. You can see that in methane, CH4, we have 4 shared pairs of electrons. And in water, we already drew this one up top, but water, again, is a molecular compound. All right, so when we talked about ionic bonds, we talked about the properties of ionic compounds, and we just reviewed those up top. So what are the 3 properties of ionic compounds? They all have a 3D crystal shape, high melting point, and they conduct electricity when dissolved in water. Now, unfortunately, I can't give you a nice, easy little chart like in the ionic compounds because covalent compounds, molecular compounds, can be so different. I mean, they can be miraculously different. To the point that I can't really say, oh, this is how they act, because they all act in a little bit differently. Let's look and see.
Hey, St. Patrick's lovers, this is
Okay, so we're going to just look at a couple of different molecular compounds, look at their melting points and boiling points, just so we can just kind of see and compare to ionic compounds. So water, we know, is H2O. And these, you're supposed to know this. What's the melting point of water in Celsius? Good, 0. Should be easy to remember, right? How about boiling point? Right, like once you remember the 0, you know it's 100. All right, methane. So methane's formula is CH4, so it's organic. And methane has a boiling point of negative 182 degrees Celsius. So that means that it goes from a solid to a liquid at negative 182. And it goes from a liquid to a gas at negative 164. Carbon dioxide, that's one you're supposed to know the formula for. What's that? Great job. CO2. That's right. And its melting point, well, it doesn't have one. It's so unstable that it goes directly from a solid to a gas. It's called sublimation. Dry ice is carbon dioxide as a solid. And a lot of times when things are being shipped that need to be kept cold, you don't want to use real ice, because real ice melts and turns into liquid and gets everything wet. If you use carbon dioxide, dry ice, it goes from a solid to a gas, no liquid state, so you don't have to worry about things getting ruined by water. So dry ice, carbon dioxide, has no liquid state. It goes directly from a solid to a gas. So what temperature does it do that at? Negative 78.6. So it doesn't even need to be above freezing in water for it to become a gas. All right, what about ammonia? Ammonia's chemical formula is NH3. So it's inorganic, no carbon there. It boils at negative 77.7 degrees Celsius. Or not boils, goes from a solid to a liquid. It melts. And it boils at negative 33.6. So we still aren't up to freezing for water for some of these things. These things are all gases at room temperature. All right, rubbing alcohol. So the stuff that you clean a cut with or whatever. That's C3H7OH. So that is, yep, it's organic, and it's also a base because we've got that hydroxide, right? We know it's basic because we have that hydroxide ion. Now, rubbing alcohol goes from a solid to a liquid at negative 89.5 degrees Celsius. But you know it's liquid at room temperature. So it's a liquid at room temperature, but at what point does it boil? What's your guess? Do you think it gets all the way up to 100 like water? Yeah, it's a good guess. No, it doesn't. It boils at 82.4 degrees Celsius. The problem is, as soon as you start boiling it, if there's an open flame, what's going to happen to your fumes? Right, so boiling rubbing alcohol is not recommended. Sugar, you're supposed to know this formula. What is it? Right, so one more time, C6H12O6. Now, sugar does have a melting point. It goes from a solid to a liquid around 185 to 186. But this would be when I would ask everyone in the room, so has anybody ever cooked with sugar before? Anybody ever made candy? How'd that go? What happened? Because a lot of the time, sugar has no boiling point. Because what it does is decomposes. It does not have a boiling point because by the time it gets to this point, it's not sugar anymore. What happens is just like before when we had the C6H12O6, and that's our simple sugar, and then we boil away 1 molecule of water for every 2 molecules of sugar, and we end up with C12H22O11, that condensed refined sugar. Well, our ratio is still 2 to 1 for our water to hydrogen. So we still have a bunch of H2Os here. And that's exactly what happens. These H2Os just boil away, and you're left with carbon. You're left with black, burned black, oogie, gross stuff. That's what happens when you put too much heat to sugar. It does not boil. it decomposes. So now that we have looked at a couple of these, how does that compare to ionic? We know that ionic had a really stupid high melting point of 801 degrees Celsius. Does that even remotely compare? No. So in molecular solids, the molecules are held close to each other, but the forces are much, much weaker than the forces holding together ionic solids. So way less energy is needed to break the bonds. So because those bonds are easier to break in a covalent bond than in an ionic bond, the boiling point on ionic bonds is stupid high, but the boiling point in a covalent bond is fairly low. All right, so pause that if you need to get any of that written down, but I'm going to clear it and move on. So we said that the things that make an ionic, the properties of an ionic bond or ionic compounds are that they have a 3D crystal shape, a high melting point, and they conduct electricity in water. So let's talk about that with molecular solids. So some of them do form crystals. So sugar, of course, forms crystals. And there's a couple of others that do. But as soon as you try to melt it or boil it, it'll give it away in a heartbeat that it's not an ionic compound. If you tried to boil salt, now I'm not saying put salt in water. We know that works. It dissolves into the water. And I'm talking about just put dry salt into a pan and turn the heat up. Your stove does not create enough heat to melt it, but your sugar would end up burning in the pan because it would decompose. Most molecular compounds are poor conductors of electricity. Because they don't have any charged particles, you don't have those ions with a charge, there's nothing to carry on the electricity, so it doesn't flow. Now, wait a minute, you say, but you're telling me that water, H2O, because they're both nonmetals, that's got to be a covalent bond. It's got to be a molecular compound. Well, if molecular compounds don't do electricity, then what in the world? How come I can't go swimming when there's a electrical storm? How come I can't go get in the lake when there's an electrical storm? Is that pure water in the lake or in the pool or whatever? No, it's got all kinds of stuff in it. It has salts in it, just period, from our bodies being in the water and all that jazz. So that's going to conduct electricity. It's got other minerals in it from all kinds of different stuff. Sometimes it's a pool. It's going to have some chlorine and bromine and it's way more than just pure water. So because it's more than pure water, it's got those ionic compounds dissolved in it. It will conduct electricity. We conduct electricity because we are just salty water, which squishy bags of salty water. And that salt water is what allows the electricity to flow that makes me be able to do this and think 2 + 2. So that's why molecular compounds such as paper and plastic are used as insulators. Cotton is also a good one. Even as liquids or dissolved in water, molecular compounds make poor conductors. Pure water does not conduct electricity, and it doesn't help if you dissolve sugar into it. Now, would it help if you dissolve salt into it? Yes. All right, so some things to add down here at the bottom, some TQA, some things to remember. You want to remember that ionic means transfer, and covalent means share. You need to know that ionic bonds make ionic compounds, and covalent bonds make molecular compounds. You need to know the 3 properties of ionic solids: 3D crystal shape, high melting point, electrical conductivity. And you need to know that molecular bonds are weaker by a lot than ionic. All right. Whew. Have a lovely day. Make good decisions. Bye.